Section 2.4 covers linear inequalities in two variables. Previously, we'd been working with linear inequalities in one variable on the real number line. Now we're going to see how linear equations relate to linear inequalities. So this is like a linear equation, except instead of equals, right, we have a less than, greater than, less than or equal to, or greater than or equal to. So instead of my solution for my linear equation being the line, the solution to a linear inequality is any point on the plane that satisfies our inequality. So here are the four different types of linear inequalities. We have less than or equal to, greater than or equal to. So let's determine whether an ordered pair solution is a solution to this linear inequation. And we're going to do that using substitution. So for part A, let's do that up here. I've got 5 times 0 plus 4 times 0 is less than or equal to 20. I get 0 is less than or equal to 20, which is true. So this point is part of the solution for 5x plus 4y is less than or equal to 20. Let's check B. If I have 5 times 6 plus 4 times 2 is less than or equal to 20, that gives me 30 plus 8 is less than or equal to 20. So 38 is less than or equal to 20. This is false. So because we got a false statement, this is not part of the solution. 0, 0 was a solution because here we got a true statement. So when we're graphing linear inequalities in two variables, what we do is we graph the linear equation, okay, and it divides our coordinate plane in half. So the half plane is the set of all points on one side of the line. So before, when we were working with inequalities, less than or equal to meant that the endpoint was included, so we'd use a solid dot or a bracket. Now we're going to use a solid line. If we're working with an inequality that's greater than or less than, whereas that used to be an open circle or a parenthesis, now we're going to use a dashed line. That dashed line will signify that our endpoint, that our line and the points on the line itself are not solutions to our inequality. Next, you need to choose a test point in one of the half plane sides, okay? And then you have to substitute the test points into the inequality. If you get a true statement, that point is in your solution, so you can shade the half plane containing the test point. But if you were, say, to get a false statement, what you're going to do is shade the half plane not containing the test point. So why don't we go ahead and work through a few examples. So here we have example 1. I've got 3x plus 2y is greater than or equal to 6. So first off, I'm going to want to put this in slope-intercept form, just so I know how to graph it more easily. So I'm going to go ahead and solve for y. I'm going to take away 3x from both sides. 2y is greater than or equal to negative 3x plus 6. Divide both sides by 2. Y is greater than or equal to negative 3 halves x plus 3. So graphed in green, my y-intercept is 3. My slope's negative, so I know it's going to look like it's going downhill. I go down 3 over 2. That's the second point of my line. Now it's greater than or equal to, so I'm going to use a solid line to connect these two dots. Next, I need to pick a point on either side of the plane in order to test which side of the half plane is in my solution. My favorite test point is the origin. This is a great test point. Why? Because it's 0, so everything cancels out. Do I have that 0 is greater than or equal to negative 3 halves times 0 plus 3? Do I have that 0 is greater than or equal to 3? No, this is false. This means my test point is not in my solution, so my solution is going to contain the other side of the half plane. So now let's go ahead and solve 3x minus 4y is greater than 0. First thing I need to do is solve for y. Negative 4y is greater than negative 3x. I divide both sides by negative 4, which means I have to flip my sign. So I have y is less than 3/4 x. What's my y-intercept in this case? Well, it's going to be 0. So let's go ahead and draw a lovely coordinate plane. All right, I'm going to go ahead and plot my y-intercept, which is 0. I'm going to go up, because my slope is 3/4. I'm going to go up 3 and over 4. So here's the graph of my line. Next, I need to pick a test point, but wait, I can't use my favorite test point, which is the origin. So I'm going to pick something else simple that I don't think is on my graph. So I'm going to pick when x is negative 1, y is 1 as my test point. So that's our test point when x is negative 1, y is 1. So I'm going to have that 1 is less than 3/4 times negative 1. I get 1 is less than negative 3/4. Is this true? No, this is false. So we aren't going to shade the side containing our test point. We're going to shade the other side. But I already made a mistake. What was my mistake? Well, I have y is less than 3/4 x. So this shouldn't be a solid line. This should be a dashed line. There, that looks kind of dashed. Now let's take a look at this last example. I have 2x plus 4y is greater than or equal to 5, and x is greater than or equal to 1. What does and mean? When we said and before, and means intersection. So I'm looking for where these two graphs will intersect. Let's make ourselves a lot more room. I have 2x plus 4y is greater than or equal to 5, and meaning intersection, x is greater than or equal to 1. The first thing I need to do is solve this equation for y so I can graph it. I'm going to go ahead and subtract 2x from both sides. I get 4y is greater than or equal to negative 2x plus 5. Divide both sides by 4. I get y is greater than negative 1/2 x plus 5/4. So let's go ahead and draw a coordinate plane. All right, I'm going to first graph when x is greater than or equal to 1. So this is going to be the line x equals 1, which would be right here. And this is a solid line because it's x is greater than or equal to. Now I'm going to pick a test point. I'm going to pick when x is 0, 0 or ordered pair, right? Is 0 greater than or equal to 1? No, that's false. So I'm going to have to shade this side. All right, next I'm going to plot in blue y is greater than or equal to negative 1/2 x plus 5/4. So 5/4 is a little more than 1. I'm going to go, my slope's negative 1, so I'm going to go down 1 over 2 and go ahead and plot my line. Now I have that y is greater than or equal to negative 1/2 x plus 5/4. I'm going to pick my favorite test point of 0, 0. I get 0 is greater than or equal to negative 1/2 times 0 plus 5/4. I get 0 is greater than or equal to 5/4, which is false. So I'm not going to shade the side containing the origin. I'm going to shade the other side. Now I'm looking for the intersection. Remember, the intersection is where these overlap. So it's going to be what I'm highlighting in pink right here. So my intersection is where I've got both blue and green. And note that because we have highlighted this area in purple, we can see it a little more clearly that this is the intersection.